Hello everyone and welcome to the chapter number 59 of Blender Master Course, Understanding the Drivers in Blender. In today's chapter, we'll be understanding about the working of the drivers, their practical usage, the driver editor, and a lot more. And yes, if you are new to this course, then you can check the previous 58 chapters from the link of the playlist given in the pinned comment. So the first question which arises is that, what exactly are the drivers? So in simple words, the drivers are the functions or the scripts which use the properties or the values to affect some other properties. In most of the cases, the drivers are used to control the animation of one property like the location, rotation, scale, etc. based on the value of some other property. Now to understand all this practically, let's first add a monkey object in the scene. So press Shift plus A, go to Mesh and select the monkey object. Let's move it in the X-axis over here. Now we'll be creating a driver that will make this monkey object rotate in the Z-axis according to the position of the cube in the Y-axis. So for this, with this monkey object selected, go to the object data properties, and since we need to rotate it in the Z-axis, so go to the rotation in the Z, right click, and here you will find an option which is add driver. So I'll select this. Now it shows some settings, but we'll be exploring them later on. So I'll take my mouse cursor away, and now you can see here that the rotation parameter in the Z axis is now turned into purple color, and this thing basically indicates that we have added a driver for this specific parameter. Now for the drivers in Blender, we also have a separate type of editor which is called the driver editor, and to open it, let's expand this timeline editor, click here, and in the animation category, select the drivers. Now if I select the monkey object, then you can see here that first of all we have the name of the object, then we have the list of drivers where we have the Z Euler rotation, which simply represents that we have added a driver for the rotation in the Z axis. Now if I left click on the Z Euler rotation, then now we have some more options in this side toolbar, and if I select the drivers over here and scroll down, then these are the same settings that we saw when we added the driver over here. You can even check it again by taking the cursor to the rotation Z in the properties editor, then right click and select the edit driver, and now you can see over here that all of these properties are exactly the same as in the side toolbar in the driver editor. Now in the end, you have the option to select an object, and suppose I left click over here, then it gives us the list of the object to be selected. So if I select the cube object, then what it basically means is that this particular parameter, which is the rotation in the Z axis where we added the driver, will now be controlled by the cube object, and since the X location is selected in the type by default, as a result, if I select the cube and try to move it in the X axis, then by doing this, the rotation of the Suzanne or the monkey object is also changing in the Z axis. And basically this is the use of the drivers. They simply allow you to control any specific parameter of an object simply by controlling some other parameter of another object in the scene. Now moving ahead, we can also view the curve in the driver editor, and to do this, you simply need to press the home button in the keyboard, and now this is the graph which is also known as the F curve. Now this horizontal axis will represent the position of the target object in the X axis, and this vertical axis will be representing the rotation of the Suzanne object in the Z axis. Now in this side toolbar, we have an option which is called the driver type, and by default, the scripted expression type is selected over here, which basically means that it will allow us to control the driver with the help of an expression. Now in the expression, the VAR means the variable, meaning that the rotation of this Suzanne model is dependent upon the position of this cube object. Then after variable, we have +0, which simply indicates the initial rotation of the monkey object. Now to understand it with the help of an example, I'll go to the expression and we'll change this from variable +0 to variable +10 and press enter, and now you can see here that the initial rotation of the Suzanne model has now changed. And if I still select this cube object and try to move it in the X axis, then in this case also the Suzanne or the monkey object is rotating in the Z axis. So whenever it's written variable plus any number in the expression, it basically means that the number is representing the initial value of the parameter which is being controlled by the driver. Also, you can see in the driver value that it shows 10 right now. However, if I change it back to variable +0, then in this case, the driver value is now equal to 0. Now you can also use this expression in order to make the rotation of this monkey object faster. And to do this, we have to change this to variable multiply, which will be represented by this asterisk symbol. And then if I type any number, for example 2, and try to move the cube in the X axis, then you will notice that the rotation of the Suzanne model is much faster than before. To see the effect in a much better way, I'll select the Suzanne object again. Let's multiply this by a much higher number like 10, and now if I select the cube and move it in the X axis, then the change in speed of rotation is properly visible now. So in this way, you can use this expression to control the initial value of the parameter, for example the rotation in this case, and also the speed of change in that parameter. Now moving ahead, the next type that we have over here is the average value, and to understand this, we first need to do some changes in the scene. First of all, select the cube, create a duplicate of this cube by pressing Shift plus D and move it over here. Now select the Suzanne object or the monkey object again, and now we'll be removing this driver in the Z rotation. So right click and select the delete drivers, and we'll be creating another driver for the location in the Z axis. So go to the object properties, and in the Z location, right click and select add driver. Now go to the driver editor, left click on the Z location, and in the driver type, select the average value. Now by using the average value, we'll basically be considering the average change in parameters of both of these cube objects in order to define the change in location of the Suzanne model. To understand it in a practical way, first we need to add both of these cube objects in the driver properties. So for the first cube object, go to this input variable, and in the object, select the cube object. Also, we'll be using its location in the Z axis in order to control the location of this Suzanne model in the Z axis. So in the input variable, change the type to Z location, and now to add the other cube, click on add input variable, and you can see here that this input variable, which was added by default, has the transform channel type. So in this new one also, I'll click here, and in the type, select the transform channel. Now in the object, select the cube.001, and in the type, select the Z location. Now suppose I select both of these cubes and move them in the Z axis, then the same change in location will also get applied to this monkey object. However, if I select any one of them and try to move it up in the Z axis, then you will notice that this monkey object is still moving up in the Z axis, but almost by about half the value of the cube. And this is because in the driver type, we have selected the average value. As a result, it is taking the average value of the Z location of both of these cubes in order to set the Z location for this monkey object. You can also view this in this side toolbar, that for the first cube, the value is equal to approximately 12, and for the other cube, the Z location value is set to 0. As a result, the average of both of them will be 12.313 plus 0 divided by 2, which is equal to approximately 6.15. And if I scroll up, then the driver value, which is affecting this Suzanne model, is equal to 6.157, which is nothing but the average value of the Z locations of both of these cubes. Now moving ahead, the next type that we have here is the sum values. And if I select this, then in this case, it will take a sum of both of these values, which are representing the Z location, and as a result, the Suzanne or the monkey object will move up in the Z axis by that added value. For example, for this first cube, the value is equal to 12.313, and suppose I select the other cube also and move it up in the Z axis by 5 meters, then now you can see that in the driver's property, the value for the first cube is equal to 12.313, and for the second cube, the value is equal to 5, which means that the driver value for the monkey object is equal to the sum of both the values, which is equal to 17.313, and you can also see this in the 3D viewport that the Z location of the Suzanne or the monkey model is having a value which is equal to the sum of locations in the Z axis for both of these cubes. Then the next type that we have here is the minimum value, and if I select this, then now it will take the minimum of both the values, or in simple words, it will take the minimum value of the location in the Z axis of both of these cubes. In this case, this first cube has the location in the Z axis equal to 12.313 meters, and the second cube has a value of location in the Z axis equal to 5 meters. As a result, the minimum value is equal to 5 meters, and therefore this monkey model is also taking the minimum value, which is equal to 5 meters. Now just the opposite of minimum value, we also have a maximum value type, and if I select this, then now it basically takes the maximum value of the Z location. So for the first cube, the location in the Z axis is equal to 12.313, and for the second cube, the location in Z axis is equal to 5 meters. As a result, the maximum of both the values is equal to 12.313, and as a result, the location in the Z axis for the Suzanne object is also equal to 12.313 meters. And with this, we now arrive to the end of this chapter. Today we understood about the fundamentals of drivers in Blender, their practical usage, then we understood about the input variable, and in the end, we also explored all of these 5 types in the drivers properties. So our next chapter will be the chapter number 60, Shape Keys in Blender. So don't forget to subscribe to our channel, press that notification bell so that you can get timely updates about the upcoming chapters. Thank you for watching, and we'll see you in the next one.